Hello, everybody. We are, for the Fish Pace Hack Week, we looked at the fish red drum and we're interested in the habitat. So we are investigating the environmental drivers to the red drum distribution using PACE. And the people in our group is Ayeshmantha, Ted, Jennifer, Retno, and me. Ron. And I wanted to point out that Ayeshmantha and Jennifer joined us from Sri Lanka and the Philippines, respectively. So they were working overnight, which is really incredible. Okay, so red drum is a fish in the Atlantic Ocean and Gulf of Mexico. It's fairly sizable, up to 8 pounds or 3.6 kilograms, and it's commercially and recreationally important. And it is increasingly found in more northern waters due to climate change. So our research area is Chesapeake Bay, and just until several years ago, it was not found in Chesapeake Bay. So that's an impact of climate change. So the main idea of our project was to use PACE data to infer drivers of red drum habitat. And we know that temperature is one of the main drivers. So ocean color would be secondary drivers. The fish data that we used is tag data. So these are fish that have tags in them. The tags issue a ping, and there are acoustic receivers that detect the pings. So the acoustic receivers indicate the location where the fish was swimming near. And what we were given from the fish researcher is the detections averaged weekly. So the detections give us the latitude, the longitude, the time, and by the tag number, the individual fish that was tagged. We have 12 individuals. The data set covers the time period June 24 to January 25, and the study area is Chesapeake Bay. So we looked at the PACE data for, we compared level 2 and level 3. For level 3, we use the 4-kilometer monthly chlorophyll, and for the level 2, we use the biogeochemical and apparent optical property bundles, and within those, the chlorophyll, phytoplankton carbon, particulate organic carbon, and apparent visible wavelength. And we also wanted to compare with the temperature, since that's a main driver, and we used the Modus Aqua sea surface temperature monthly 4-kilometer. So this is the study area at Chesapeake Bay on the east coast of the US, and the right-hand graphic shows the distribution, the spatial distribution of the acoustic receivers and the weeks over which the receivers were detecting the fish. As you see, June 24 to January 25. So the method, I have a slide on level 3 and then on level 2. For the level 3 data, we extracted the PACE data for the region of interest, and the idea was for chlorophyll, and the idea was to make maps over time with the red drum locations for the time interval of the PACE level 3 data. And we also did the same thing with the temperature data. And then for level 2, we gathered the PACE granules for the BGC and AOP bundles. The fish data is in a 7-day week, and we collected granules in a 5-day window around the center. of the 7-day week, and then we averaged those together to fill gaps. We did similar for monthly. And again, the pace variables are chlorophyll A, phytoplankton carbon, POC, and AVW. And from the level 2 data, we extracted the pace variables for the red drum latitude, location, and time. And we did that in order to do a statistical comparison of the potential drivers. So we did scatter plots of the chlorophyll at the red drum locations, the phytoplankton carbon, POC, and AVW versus latitude. And then we did the same as time series using the week of the average detections.
Right, minute and a half warning.
Sorry?
Minute and a half warning.
Okay, I'm sorry. I spent too long on all that. So this is the temperature, very seasonally, of course. The chlorophyll, this is the monthly chlorophyll. I'm going to go to the weekly chlorophyll. The detections are clustering in the northern part here. But then in the by October, the detections are really spreading out. That's similar for the level 2 data. I wanted to point out in the AVW, here you can see better that the detections cluster where there is high ocean color variables, and then spread out, and then a very small number of detections in the winter. But here, this was an interesting finding where the AVW is high. We have we still have a detection. So I think with limited time, I just want to point out the time series, that the chlorophyll decreases, or there's lower chlorophyll later in the year for the detections, and the same with the POC, and the in the statistical analysis, what we wanted to point out that there's a clustering of the AVW around the 550 area. So for our results, we're seeing that there's high productivity in the ocean color variables in the north. In the summertime, and the red drum is appearing where there's high AVW. So we are able to say a few things about the environmental influence on habitat. I'm not going to read through those. I wanted to get to the hypotheses. I think it's really incredible that we were able to come up with hypotheses. So we're interested in knowing whether the red drum moves seasonally, based on food availability, which is suggested by the chlorophyll A and the POC. And the AV, we're wondering if the AVW may be a good discriminator of red drum location, because we had in the statistical analysis and in the spatial maps, we had an alignment of the detections where there was higher AVW regardless of the season. So that was an interesting finding. Do I still have time left? Am I over?
You're a little over. You can go ahead and finish your slide there.
So the challenges, well, let's see what's more important. I'll just talk about the challenges. We had to wonder about the best spatial and temporal interval. So the issue was that we had 7-day fish data and 8-day satellite data. So there are fish detection overlaps in neighboring weeks. The same is true for the monthly data. So that's something that would have to be done in a more refined way.
All right.
Well, let me just finish with our last slide that we really appreciated the Fish Pace Hack Week. We learned an incredible amount. Our group said that we really enjoyed working together and we're going to stay connected. Thank you.